Saturn is one of the most fascinating planets in our solar system. Known for its spectacular rings, it is also famous for a surprising scientific fact. Saturn is the only planet that could theoretically float on water. This idea sounds impossible at first. After all, Saturn is the second largest planet in the entire solar system. Its diameter is more than 9 times larger than Earth's. Yet despite its enormous size, Saturn is incredibly light for a planet. Scientists measure this using something called density. Density tells us how much mass is packed into a certain volume. Saturn is made mostly of hydrogen and helium gases. These elements are extremely light compared to rock or metal. Because of this, Saturn's average density is very low. In fact, Saturn's density is lower than the density of water. Water has a density of about 1 gram per cubic centimeter. Saturn's average density is only about 0.7 grams per cubic centimeter. This means that if there were a bathtub large enough, Saturn could float. Of course, such an ocean would need to be unimaginably large. In reality, no ocean in the universe is big enough to hold an entire planet. But the comparison helps scientists understand just how light Saturn really is. And it reveals one of the most surprising facts about the ringed giant. Scientists compare Saturn's density to water to explain how unusual this planet really is. Density measures how much mass is packed into a certain amount of space. Rocky planets like Earth are dense because they are made of heavy elements. Saturn, however, is composed mostly of hydrogen and helium. These gases are extremely light compared to rock or metal. As a result, Saturn's overall density is surprisingly low. In fact, Saturn is the least dense planet in the entire solar system. Its average density is only about 0.7 grams per cubic centimeter. Water, by comparison, has a density of about 1 gram per cubic centimeter. That simple difference leads to a fascinating thought experiment. If there were an ocean large enough, Saturn could theoretically float. The idea sounds strange because Saturn is enormous. The planet is large enough to hold more than 700 Earths inside it. Yet its lightweight composition keeps its density extremely low. Of course, no ocean in the universe could actually hold a planet this large. But the comparison helps scientists explain Saturn's structure. It reveals how gas giants are fundamentally different from rocky planets. Inside Saturn, pressure increases dramatically toward the core. Deep layers of hydrogen may even behave like liquid metal. These extreme conditions help shape the powerful planet we observe today. Saturn is not only unusual because of its low density, it is also surrounded by one of the most spectacular ring systems in the solar system. These rings are made of billions of icy particles. Some pieces are as small as grains of dust. Others are as large as mountains. All of them orbit Saturn together in a vast, thin disk. Sunlight reflecting from these particles creates the bright rings we see from space. Although the rings appear solid from a distance, they are mostly empty space. Each particle follows its own orbit around the giant planet. Saturn's gravity keeps the entire structure in motion. The planet also has dozens of fascinating moons. Some of these moons help shape the structure of the rings. Their gravity creates gaps and waves inside the ring system. One of the most remarkable moons is Titan. Titan is larger than the planet Mercury. It is covered with thick clouds and lakes of liquid methane. These moons and rings make Saturn one of the most complex systems in the solar system. Together, they form a miniature planetary system around the giant planet. Studying Saturn helps scientists understand how planets and moons evolve. And it reminds us that even familiar planets can still surprise us. Saturn's system of rings and moons makes it one of the most extraordinary planets in our solar system. Dozens of moons orbit the giant planet under its powerful gravity. Some of these moons are worlds with their own unique environments. Titan, Saturn's largest moon, has thick clouds and rivers of liquid methane. Enceladus hides a global ocean beneath its icy crust. Powerful geysers on Enceladus shoot water vapor high into space. These discoveries suggest that even distant moons can be active worlds. Saturn itself continues to fascinate scientists with its unusual structure. Beneath the clouds lies a deep interior of compressed hydrogen. Pressures and temperatures increase dramatically toward the planet's core. Some scientists believe metallic hydrogen may exist deep inside Saturn. This exotic material helps generate the planet's powerful magnetic field. Despite its enormous size, Saturn remains incredibly light for a planet. Its low density is what makes the floating comparison possible. The idea of Saturn floating on water is only a thought experiment. but it highlights the strange physics of gas giant planets. Saturn reminds us that planets can be very different from Earth. Giant worlds made mostly of gas behave in surprising ways. Exploring these planets helps scientists understand how solar systems form. And Saturn remains one of the most beautiful and mysterious giants in space.